Okay, I know that I am the last thing between you and lunch, so I will try to end on time. To do that, I am going to need your help, though. So we're going to do an experiment, which I know has you feeling like this right now. So doesn't matter. I'm sorry that you feel that way. Here's what we're going to do. I need you all to stand up. And then we're going to sing If You're Happy and You Know It. I'm not kidding. You're all laughing and you think this is a joke. This isn't a joke. I'm going to record this as well. So here's your starting note. It's going to be something like, if you're happy and you know it, clap your hands. If you're happy and you know it, clap your hands. If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands. All right, thanks everybody. You can sit down. Okay, 3 things really quickly. And since I am the third in the trifecta of pull request and code review talks, you probably already know this one, but this is what Google says. We're going to look at 2 quotes from Google about this. I'm not going to read it. I'm going to let you read it. I'm going to pause for a moment while you read it. These both come from Google's very excellent code review document, which if you search for Google code review, you'll find a whole website that they've created about doing good code reviews, the purpose of code reviews, all those things. If you haven't read it, read it. If your team is looking for some guiding principles and some guiding documents for code reviews, Google's already written it, and you can just pick it up and go with it. Number 2, what are humans good at? A lot of things, from doing this to doing this. Who doesn't love Bob Ross? He's great. To this. I'd like to see your self-driving car do that. So really, like, we can kind of pull out these points, right? Humans are good at adapting. We're good at creativity. We're good at abstraction, both creating and understanding abstractions. We're good at imagination. I've separated that from creativity because I think they're 2 different things. We're good at understanding language. Natural language processing is getting better, but it's still pretty hard. We're good at emotions and a whole lot of other things. Now, you may question whether or not we're good at emotions. I'll say we're better at emotions than computers, which is a very low bar, honestly. What are we bad at? Following directions. Now, I was expecting like maybe 30% of you to stand up and sing with me. There were a few of you who were very hesitant and eventually got peer pressured into it by everyone else doing it. Some of you I noticed were not clapping. So like as a whole, any of you who have children or have worked with children or have worked with software developers or have worked with other humans know that they're like, we're very bad at following directions. Even when we want to be good at it, we tend to like interpolate our own ideas to what the directions were and do that instead of the actual directions. Rapid iteration. We're not really good at rapid iteration. Repetition. We're not very good at repetition. Just think back to the tongue twisters you tried to say as a kid. It's hard. We're bad at parallelization. Anyone who tells you that they're good at parallel work doesn't know themselves very well. We can really focus on one thing at a time. If we're trying to focus on more than one thing at a time, what we're really doing is maybe at best rapid task switching. But realistically, we're not even doing that because we're not good at switching context that quickly. That's why you shouldn't drive and watch YouTube videos at the same time. Math. And let me like asterisk math real quick. We're good at coming up with mathematical concepts. We are not as good at doing math and running functions in math in our head as computers are. They're better at it than we are. They might not be able to figure out the underlying concepts like we could, but that takes us back to creativity. Okay, so computers, they're good at many of the things that we're bad at. This is a very simple example. Wow, that is really grainy. I am sorry. What you're looking at is an antenna that was designed by an evolutionary algorithm for use on a spaceship, on the ST-5 spacecraft. This design was orders of magnitude better than anything that humans had designed before. And it was done by proposing a direction in the algorithm and then testing it to see if reception had gotten better or worse. So this is where that rapid iteration comes in. Is this creativity? I would argue no. You might argue differently, but this is rapidly testing if something has improved or gotten worse. Computers are very good at this. And then there are many things they're bad at, like as our counterexample. I don't even need to say anything about this. But if any of those chihuahuas are making you hungry, it is almost lunchtime. Yeah, so back to the point. There is nothing like getting to the point. So let's talk about code reviews. What parts of a code review are humans good at? Because what we want to do, we want to optimize, right? Because we're engineers, we like to optimize things. We want to find the parts of a code review that we are good at and do them. And we want to find the parts of a code review that a computer is good at, and we want to let a computer do those. Both because it will work out better that way, but also because a lot of the things that a computer is good at in code review are things that you dislike about code reviews. Because there are things we all dislike about them. So what are we good at? Thinking about how we're good at abstract thought and understanding language. It would be very difficult for a computer to take your Jira ticket or insert your ticketing system ticket. It would be very hard for a computer to take that ticket and understand whether a pull request met the requirements of that ticket. Because there's context from having met and talked with designers, from looking at comps, from having designed the underlying data systems that are not going to be present in the acceptance criteria of that ticket, more than likely. But you as a human, you're very good at reading that ticket, connecting all of those dots, and understanding what the code is supposed to be doing. Identifying if code is idiomatic. This does not mean idiomatic to the language. I mean idiomatic to the code base. You can have really non-idiomatic JavaScript that is idiomatic to the code base you're working in. And all of your pull requests should try to stay within the bounds and the patterns that exist within a code base. Yeah, recognizing exceptions. This is going to come back towards the end of this presentation, but understanding when you should make an exception to a well-understood and a well-accepted rule is something that we're good at as humans that computers are not good at. And other things that I haven't mentioned. So what parts are computers good at? So computers are really good at matching patterns, right? If you tell a computer to go find every document on your computer that has the word "the" in it, it will do it, and it will find them all, and except the ones that have capitalized "the" because you forgot to tell it to be case insensitive, and it's very, very literal, and it's very good at matching whatever the pattern is that you tell it to match. They're also good at meta-analysis of code. Talk about that in a second. And they're good at enforcing standards. Enforcing standards often looks like matching for a pattern and then doing something about it. Meta-analysis of code, though, is more than that. And to introduce us to some of the ideas, I offer you this bit of possible wisdom. What is a bug anyway, if not a misunderstood feature? which sounds crazy. This is actually an idea that comes from a paper from the late 70s, early 80s by the computer scientist Peter Youre. If you've worked with me before or talked to me about computers before, you've probably been sent to this paper to read it. It's called Programming as Theory Building. If you haven't read it, you should all read it. Google for it. It comes up first result in PDF form. But what he's talking about is how it's hard to understand software and how the nature of it being difficult to understand is tied into the same way that we understand the world through scientific theory, and that there are dramatic similarities between the two. What he says is that when you need to make a modification, first of all, you have to confront the existing solution and then look for what needs to be modified. So you have to understand how it's already working in order to make the modification. Microsoft got really interested in bugs back in the late 90s, early 2000s. So shortly after Windows Vista, they did a whole bunch of research. And one of the things that they found was this, that we find that in all cases, measures of ownership, such as the number of low expertise developers and the proportion of ownership for the top owner, have a relationship with both pre-release faults and post-release failures. That sounds like they're making fun of us by calling us low expertise developers. But what they mean is the number of times that a file has been modified by someone who wrote less than 20% of that file previously. The more of that file that was written by a single person, and the answer to whether that single person is the person who is making the modification, if the person who wrote the whole file is modifying the file, the chances of a bug are very low. The more people you get into that file making changes, and the less an individual has changed in that file, the more likely they are to introduce a bug. Goes back to Peter Youre, right? It's a theory. If you don't fully understand the theory of the thing, it's very easy for you to make changes that violate the theory that you don't understand. So my first attempt at making something that helped do this meta-analysis, and in particular the meta-analysis that it was designed to do, was identify who owned a file and make sure that they were on the code review for that file. It was called Pythia, named after the oracle at Delphi. She gazed into her mirror and came back with answers. And Pythia gazed into the past of the code and came back with answers as to who should actually be reviewing the code. And this sort of started this journey for me of figuring out how to provide useful hints both to reviewers and to developers in an automated way that focuses on the things that computers are good at while leaving the things that humans are good at to the humans. Another great example of this is the Rust-lang compiler. So anybody written Rust? Okay, a few of you have. Then you're probably familiar with the errors in Rust. They're sort of legendary. They're insanely helpful. This error is because you tried to reference an item called D on struct that doesn't exist. And being as wise as it is, it suggests that maybe you meant B, because B and D look alike, and there is a B on the struct. Super helpful, right? This is a compiler teaching you how to write code and teaching you what your error is, rather than just printing out an error. We write JavaScript. We're all familiar with scrolling through acres of incomprehensible error messages. This is amazing, and it takes a lot of work. When I worked at Instructure, some of you also worked at Instructure, and you'll be familiar with Gurgich. Gurgich tried to do this to a certain extent as well. It was a part of our build process that reviewed your code, did some static analysis, and then if you wrote something that was not particularly idiomatic, or if you violated one of your specific team's standards, it would give you suggestions about how to not do that thing. Girgich really only worked with Ruby, and it was very much like an internal instructor thing that has never escaped, and is probably locked up there permanently. So that brought me to writing something similar. So in the last 8 months, I've been working on a little thing called Lobot. If you remember Lobot, it's a little tiny minor character in Empire Strikes Back. Only appears in a couple scenes. He's half man, half computer. It's what we want for our code reviews. We want him to be half man, half computer. So Lobot, his job is to add additional options for linting and meta-analysis, because there are things that we can be helped with. So its main goal is to provide focus hints for reviewers. So for instance, I'll just show you this next one. This is actual output from it in our build process. It includes a how do you do a code review step by step that's by default collapsed in the comment that it leaves on the PR. If there are errors, so errors are things where it breaks the build and prevents you from moving forward. For us, we only have 2 things that do that right now. You need a test plan that tells the reviewer how to test your code, and you need to have a ticket in the code or in the PR body so that we can track the change in our change system. And then it has a section for reviewers, and it says, hey, there are no tests found for these files. Now, part of the reason here is that it doesn't understand spec.spec.js, and I need to remove the playwright file directory from it. But the other thing that you can't see is that it calls out the size and the number of files that are changed. And says, hey, there's a lot of files that were changed in this, or a file was changed significantly. Make sure you pay careful attention there, or suggest that this be broken down into smaller pieces. As you progress through and answer, each thing, it becomes progressively happier until you get the thumbs up, and you can kind of move on. These are examples of things that it can do now and that you might consider doing in a system like this for your code base. So I should back up for a moment. It's really hard for you as a human to know who has the best mental model for a file that you're working in. You can get blame a line or two, and that will tell you who wrote that line or who understands that line, maybe that function. But doing that in a focused way is unlikely to tell you who knows the file the best. But a computer can do that pretty easily, right? It looks at the get blame for every line. It pulls out how many lines are owned by each person, and by that knows who knows this file the best. Another example of this is it'd be very easy for you as a code reviewer to look at a bunch of files and say, oh yeah, well this one was changed quite a bit, but it looks mostly the same. I'm just going to say it's fine. Whereas if we pull in the person who wrote the file, they may notice that you added a ternary or dropped a ternary and thus had changed something fundamental about the file. So, Daniel, why don't we just have fully automated code reviews? Like, why can't we just let static analysis do all the work for us? Well, we could, but it would be a terrible idea. And the reason is that we need to be able to make judgment calls. We talked earlier about how humans are good at making trade-offs and good at evaluating whether something is actually necessary. If you do a really good refactor, Lobot won't know that there shouldn't be a change to the test file, right? It just assumes if you're touching a file that there needs to be an accompanying change to the test file. Oh no. Okay, there we go. Okay, we're running short on time. So What are other things that you could receive hints for? This is actually a rhetorical question. I'm not going to give you the answer for it. But think about the patterns that you have on your team, how you structure a pull request, how you name your files, how you structure your directories. All of those are things that are ripe for pattern matching, right? All of those are things that you could use a code review assistant to evaluate for you. And then you can get into the more interesting things like, what about where you have a new function, a new private function? You could call out whether or not you think that's a good idea as a team. You could look at how much of a file changed and call out whether or not you think that is a risky change based on percentage of file change. There's a lot of meta-analysis that you can start to do. You can even start to call out areas of the code base that you expect to be buggy or you think might need some extra manual testing because the files that are in them have churned a lot. A lot of people have touched them. You can start to call those things out as part of your code review, which for you as a human, you may intuitively know some of that, but it's going to be very difficult for you to have the specific details of it. So all of this has been a very long way of saying you don't have to use lobot. I'm working on getting it actually published somewhere and open sourced and available if you do desire to. But what you really should do is look at how you can set something up similarly. Static analysis is amazing. So is Git history analysis. But you should only do these things in accompaniment with, the other things that you should do. Testing, lints, all those things, right? So you want to have lints, you want to have tests, you want to have actionable meta-analysis on the code because all those things lower the overhead for you to do a code review and help improve the quality of the code review that you're doing. Okay. Because this is really what it comes down to. Right? There's two goals in having an automated code review assistant, whatever form that takes for you. The first goal is to do the parts that you're not good at, to catch the things that if you paid super close attention to and spent days doing your code review, you would notice, but that you're not going to do because no one's going to do that. And then also to make it easier for everyone to participate in code reviews. You do those two things and you improve your quality, you improve your, as we talked about, team culture, and you end up with better code and happier people. So that's the end, and it's lunchtime, I think. So I'm Daniel Sellers. I am hiring. If you scan this giant QR code that is way too close to my name, then you will land on a landing page that will tell you about 3 roles that we've got open right now. And also come talk to me. If you have questions, if you have thoughts, just come grab me or shoot me a message on Twitter or shoot me an email, daniel@designfrontier.net. Thanks, everybody.